Hello student, how are you? I hope you are fine. Students, I want to say two things here. First is subscribe my YouTube channel so you can't miss out the upcoming video. And second is through perseverance and hard working we would able to achieve our desired goal. In our previous lecture I discussed about the simple harmonic motion, whether the motion is in given equation, finding the motion is oscillatory or periodic or simple harmonic motion, and we also discussed few relevant problem, and today I am going to discuss here few relevant problems. So the first problem is here a, a disc is here hinged with a vertical rod, and this rod having no mass. This rod is massless, and a torsional wire is attached with this spring. Torsional wire is attached with this rod, and we have to calculate in this scenario the frequency of motion. And in first scenario, this shows that the disc can undergo to SHM and find the frequency of motion. So we have to find the frequency of motion. We know omega is equal to, this is angular frequency, this will be 2 pi f, and f is the frequency of the SHM, and we write here the torsional torque would be I into alpha. This would be I into alpha, and this would be minus c into theta. Theta is the angle, torsional angle. This would be like that, theta. So the for disk, the moment of inertia for the disk is mr square by 2, and this is alpha minus c theta. So alpha becomes 2c by mr square into theta. This is alpha is equal to minus omega square theta. This is the equation of SHM. So frequency becomes 1 by 2 pi under root 2c by mr square. This is omega, and right frequency would be omega by 2 pi. So this is the frequency. In first part we have to calculate out the frequency, and the second part, suppose the disk is moving according to the theta. This is A part, and in B part we have to calculate here the disk is, this is the amplitude of the angular, this is angular amplitude, equation of angular amplitude, and at time t is equal to pi by omega, a ring is docked concentrically on the disk. This means here a ring is placed over here on the disk concentrically, and we have to find the new frequency and new amplitude. After that scenario, after that position, we have to find the new frequency and new amplitude. So the angular displacement equation is theta is equal to theta naught sin omega t. When t is equal to 0, then theta is equal to 0. This is mean position. And when we place the t is equal to pi by omega, then theta becomes theta naught sin omega, omega cancel out. So this becomes pi, sin pi is 0. So theta also becomes 0. This means this is the mean position. Because of we calculate the time period for that position, omega is equal to 2 pi by t, and omega is pi by omega, t is equal to pi by omega. So t would be pi by omega. So time period is equal to 2 pi by t, omega is equal to pi by omega. So this becomes, time period becomes t by 2. time becomes T by 2. So this means this is doing SHM, and after T by 2 time, this position becomes the mean position. So in that position, we know the at mean position, any of the uh, object is doing SHM, the amplitude and the velocity would be maximum velocity. This would be a omega if the motion is linear. Well, what we here we talking about the angular velocity, that would be theta naught omega. So omega naught is the, suppose angular velocity is initial, and this is omega naught. So this is a angular velocity, and this is angular frequency. This is angular frequency. This is angular velocity. So angular velocity would be at mean position would be theta naught omega naught. This is the angular velocity at mean position. So angular velocity at mean position will be maximum. So this would be the angular velocity, this will be angular velocity at mean position. So we have to calculate here the final amplitude and final frequency, new frequency. So the scenario is on putting the ring. So on putting the ring, so then torque becomes minus c theta dash, and torsional constant is fixed. Torque would be, so torque would be I into alpha, so alpha dash, so minus c theta dash becomes theta dash. So we write here, so moment of inertia of disc and moments of inertia of ring. Ring is placed here. Here the disc and ring is concentrically placed. Same radius, same mass. It, this is a disc or this is a ring. Ring is placed on disc. So moment of inertia of the ring, that is mr square into alpha dash minus c theta dash. So alpha dash becomes, this becomes 2 c by 3 mr square into theta dash. So frequency would be 1 by 2 pi under root 2 c by 3 m r square. This is the new frequency. This is new frequency of the system while we placed a ring on a disc concentrically. So this is new frequency, and we have to here calculate the amplitude of the SHM. This is angular amplitude. So we conserve the angular momentum initial and angular momentum final. So angular momentum initial I1 omega 1 and I2 omega 2. So I1 is mr square by 2. Moment of inertia of the first condition when the only disk is rotating. So omega 1 would be omega, this is omega naught and this is theta naught, and I2 would be 3 mr square by 2. Moment of inertia of the disk plus moment of inertia of the rod. This would be omega, we have to find here omega dash. So omega dash would be under root 2c by 3 mr square. This is omega dash, new angular frequency. So this would be omega dash into theta dash. Theta dash is the new amplitude. So mr square by 2 into omega naught. Omega naught is what? Under root 2c by mr square, and 3 mr square by 2, and omega dash would be root 2c by 3 mr square into theta dash. So here we see mr square cancel, and 3 root 3, this becomes root 3 here, and this term also cancel. So theta dash would be, this is theta naught. Theta dash would be theta naught upon root 3. This is the angular amplitude. So in this problem, we have calculated out the angular amplitude of SHM. This is a angular SHM. In this problem, torsional constant we have given C, and this is a disk. In primary condition, in initial condition, we have find the frequency of the system, and when the ring is placed on concentrically on the disk, when we find here the new frequency of the system and amplitude of the system, that reduces because of here moment of inertia increases, so angular amplitude would be reduces. So we find the angular amplitude here. So next problem, this problem is asked in IIT JEE Advanced in 2026. So in this problem, a rod is given, and this rod is submerged in a liquid having different densities. So half container is filled with density 6 rho, and half is container is filled by the density 2 rho, and the rod having the density, this is the situation, and here the rod is here, and this rod is, sorry, this rod is hinged, this is a rod, and this rod is hinged about, this rod is hinged about this point. Suppose this is O point, and half portion of the rod is submerged, and this half portion of the rod is submerged by another liquid. The density of this liquid is 2 rho, and this liquid is 6 rho. A is the area of cross section, L is the length of the rod, and L by 2 here is, this length is L by 2, and upper length is also L by 2. So we have to find the time period of the rod, time period of the rod. In this scenario, we see here, if we tilted a rod, this rod by some theta from original position, this is a vertical position, original position, we tilted this rod, this is, so this is 6 rho density, this is 2 rho density, and this having density rho, area A, and length L. So cross section area is A here. This is a rod having area of A. Suppose we, so here the at L by 2 distance, here the gravitation force is acting downward, and at that particular portion the buoyant force is acting upward. This is FB, and at that point buoyant force is acting upward. This is FB dash. So here see over here, the density of both liquids are different. So by the density of this liquid, the buoyant force is acting only this length. This is L by 2. This length is also L by 2. So buoyant force is acting on this length would be FB dash, and this length would be FB dash. Buoyant force acting on a body submerged portion, only submerged portion. Buoyant force acting on a body while it's submerged portion, we have to calculate out the buoyant force by the submerged force. So Fg would be mass of the rod, density of rod is rho, and volume, area, cross section area is A, and length is L and G. This is the gravitational force, and we have right here mass of the rod. Mass of the rod is rho Al. This is the mass, and buoyant force Fb would be this length is, so density of for that upper portion, density of liquid is 2 rho, and area is A, and buoyant force is acting at L by 2 distance. So this becomes L by 2 into G. So Fb dash would be 6 rho is the density, A is the area, L by 2 is the length, and G. So this becomes 3 rho A L G. This is the buoyant force, this buoyant force. And we have know at that point we have taking torque at O. So this distance, suppose this is R1, this is R2, suppose this is R1, and this distance from here to here, this is R. So we calculate out the distance here. So R1 would be this distance. This distance is Ly2 plus Ly4. So this distance would be Ly2, 3Ly4. So 3Ly4, this distance is 3Ly4. So R1 would be 3Ly4 sin theta. This is hypotenuse or this is perpendicular. So perpendicular becomes 3Ly4 sin theta. And R2 would be this. This is Ly4. This is total Ly2. So this distance becomes Ly2, Ly4. So Ly4 sin theta. And R becomes, this is Ly2, this is Ly2. So Ly2 horizontal, vertical, Ly2 becomes Ly2, R becomes Ly2 sin theta. So we take torque here. Torque would be Fg, R cross Fg minus R1 cross Fb minus R2 cross Fb dash. So torque is equal to I alpha, moment of inertia of the rod. This is ml square by 2, ml square by 3. This is the moment of inertia of the rod about this end. About the center, it is ml square by 12. This is ml square by 3 into alpha. So R into Fg, R would be Ly2 sin theta, Ly2 Fg will be rho A Lg sin theta minus R1 3Ly4 R1 Fg R1, this is R1 Fb. So this becomes 2 rho Al by 2. 2 cancel out. So minus sin theta here. Minus this is Ly4 into 3 rho Alg sin theta. So we write here mass of the rod. This is rho Al and L square by 3 alpha. So on solving this, theta becomes theta. So sin theta would be for a small angle theta. So we write here. So L by 2, 3 L by 4 and 3 L by 4. 3 L by 4, 3 L by 4, 3 L by 2. 3 L by 2 minus plus 3 L by 2. 3 L by 2 means L. So this becomes rho A L G into theta. Sin theta is equal to theta. Rho Lg and L is also here, so rho L square. So this becomes L square, rho A cancel out, and this is minus. So alpha becomes minus 3GYL into theta. So alpha becomes minus omega square theta. This is the equation of SHM. So we write here time period would be 2 pi under root Ly 3g. This is the time period. This question is asked in this year in IIT Advanced, JEE Advanced. So not difficult, some analytical question is here. So this is the problem. So another problem, in this problem a spring mass system is given, and a bullet is strike. Initially spring mass system is at rest and bullet is strike on the mass and embedded in it. The scenario is here the spring and this is the mass m, and this is the placed on a horizontal plane. This is plane, this is plane, and spring has spring constant k, and this is a bullet having mass m and initial velocity of v naught. So this bullet is striking on a mass that is attached with a spring having a spring constant k. We have to find the amplitude of SHM, or say the amplitude of mass is doing SHM while the bullet strike on the mass. So we here understand the phenomena, the spring force, spring force and gravitational force, gravitational force, both are non-impulsive. Both are non-impulsive. Both are non-impulsive. Both are non-impulsive because we here we understand what is meant by impulsive force. The process of hammering is impulsive. Process of we when a car met with an accident, this process is also impulsive. Impulsive means this process is happening in fraction of second. Friction of second means hammering on a object and accident of a vehicle. This incident happened within a fraction of second. So these are the impulsive force. These are force are very large, but gravitational and spring force is very small in comparison to. For the impulse is the equal to change in linear momentum, we know. So here impulsive force is very much, so for nominal time, for very small time, fractional time, this force would be very hammering, like a hammering or accident of the vehicle, creating the force is very large. While the gravitational or spring force, these are these are time taking force. So for the change of linear momentum, this should be take time. So there is no impulse. Assumption of impulse is here worthless. So we, that is why, that is the reason we conserve the momentum in the air while the atomic diffusion is there, uh, bomb diffusion is there. So we conserve the momentum because of the gravitational force acted here. Suppose Here this force is non-impulsive. So in this scenario, we have to conserve the momentum. Initial momentum is equal to final momentum. This momentum is just before the collision and just after the collision. So the force not affected the momentum here, because this spring force is also non-impulsive. So we conserve the momentum here. The mass of the and V naught and mass of the block, that is capital M. So this becomes 0, and finally M plus M into V naught. This is the mass of the bullet, and so finally we got the mv naught is equal to upon m plus m. This is the velocity of the this in this collision. This is an inelastic collision. This is an inelastic collision. So while the bullet strike on the mass, it's embedded inside the mass, embedded inside the mass. So we find the velocity here, combined velocity for both system. So we have to find the, this is the normal length of the system, this mass system. This is normal length of the mass system. And on striking the bullet, this at that moment, the this would be the position of mean position. This would be mean position. Means this is the equilibrium position. This natural length would be the mean position of the this mass. This is mean position because of the spring force is non-impulsive force. So this is mean position. We know at mean position the velocity of SHM or mass would be maximum. So velocity would be A into omega. So velocity is here m v naught m plus m into a. This is amplitude here. So amplitude we have to calculate, and omega would be under root ky m plus m. This is the omega. So amplitude would be m v naught upon under root k m plus m. So here we find the amplitude of the system. And another problem, here in this problem we have to find the time period of the system. This is system like as this is a spring and a pulley is attached. This is massless and frictionless pulley, and here this length is fixed and a mass is suspended here. So spring constant is k. We have to find the time period of the block. Time period of the block. In this question, we have to find the time period of the block. So if we assume the tension T is applied here, tension T is applied here, so T tension would be here. We know T into X summation of that would be 0. We know by the constant motion the summation of all the forces, this is internal forces, all the internal forces would be 0. So we write here for the mass the tension is T, and suppose here the displacement x2, and we have to find the x2 for the value of this extension. So T into x naught would be 2T into x2. So x2 becomes, this becomes x naught by 2. So this would be x naught by 2. The extension in the spring would be x by 2 if we suppose this is mean position and this is the extended position x naught. So this is extension is x naught, then the extension in the spring will be x by 2, x naught by 2. So we conserve the energy, potential energy of the spring. So write here potential energy of the spring, kinetic energy of the block, and this would be negative, and this is constant force, the gravitational potential energy mgx naught. This is constant, and total energy is constant. So spring energy will be half kx square, x is equal to x naught by 2, so this would be x naught by 4, and kinetic energy of the block half mv square, and this is mgx naught, this is constant. So on differentiation with respect to x, differentiation with respect to x, so this becomes 2 2 by 2 k by 4 into x naught plus half m v square differentiation 2v dv over dx, 2 cancel out, and minus mg, x naught is mg, and constant term 0. So this becomes 2 cancel out, kx naught by 4 plus m v dv into dx, this is acceleration mg. So acceleration would be, we know, dv by dt, and on multiplying by x dx, so this term dx by dt, this term become v dv over dx. So we write here v cross dv by dx, v cross dv by dx is equal to acceleration from here. So we write here ma would be minus kx naught by 4 plus mg. Mg is a constant force. Constant force. This force not affected in SHM, only this affected the amplitude of SHM, but time period is not affected by this force. As we know, the if the spring mass system is here, the suppose this is mass and this is the spring mass system is here in this incline, so this force is acting mg sin theta. Mg sin theta would be component here, and this is, so this is constant force. Agar we say this is mass m, then the time period would be 2 pi root m over k. So this is fixed for here. If we summarize this scenario, if we summarize in liquid, suppose this is a liquid and this is a spring system, and this is a mass here, and m and k, and this is this whole spring mass system is submerged in liquid, then the time period would be m by k. No band force is affected on the time period of the this is so this driving force, this mg sin theta not affected here, this band force not affected here. So time period for the spring mass system is always constant. So in this scenario, we see here this is a constant force. So the time period, this is the equation of ma equal to and divided by minus k by 4m and x naught. This is omega square minus x a equal to, this is equation of SHM. So right here time period, this would be t pi 2 pi root m 4m over k. This is the time period of SHM. So here we discuss another problem. So in this problem, this is the, in this problem, a spring and a wedge is given. Suppose in this problem, this is the scenario here, and uh, this is the scenario here. Suppose this angle is 45 degree, and here the spring is attached here. this thing having spring constant K, and this spring also has spring constant K. We have to find the we have to find the amplitude of the displacement, amplitude of the so in this scenario we see here, if we wedge, this is a wedge, and wedge having mass m, if we displace this wedge, the scenario like this becomes, and this if we displace this wedge, x displaced here, suppose this is x displaced here, so what happened when this block is x displaced? So this is x, this is also x, so this is also x. So this angle is 45, so this angle also be 45. So the this length, this is x, and this would be x sine 45. This length would be x sine, this x sine 45, this would be 1 x by root 2. This length would be x by root 2, and this length's horizontal component, they are, when the displacement is in this direction, then the force of spring force would be in this direction. We have displaced in this direction, so force would be in this direction. So in this direction, we have to calculate the force in this direction by this spring. So force would be this in this direction by this spring. So this is the free body diagram for this spring. This force is not horizontal, so we have to take the component of this distance. So the component of this distance would be x by root 2 cos 45, and the spring constant is k, so the force becomes kx by 2. This is the force, this force and this force in same direction, and displacement in this direction. So restoring force would be kx plus kx by 2, and this becomes 3kx by 2. So the mass is m here, so we can write here m into a. So a 3k by 2m, 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 2, sorry, this is a, 2m and x. Because of the force is acting in this direction and displacement is acting in this direction, so we take negative sign here. Because of displacement in this direction and force in this direction, so this would be the omega square x. This is the equation of SHM, and we write here the frequency and time period. This would be 2 pi under root 2m by 3k. This is the time period. So we discuss here the problem, and we have to find the SHM in adiabatic process. When the SHM in thermodynamics. So suppose This is a piston here, and piston having mass m. This piston having mass m, and this is a diathermic. This is a insulated valve, or say adiabatic valve, and adiabatic piston is here, and we have given the initial pressure and initial volume of the gas inside the chamber is P naught V naught, and this is also P naught V naught. We have to find the time period of the piston having mass m. So when we displace this piston x naught distance, and the area of the piston is A, this is given. Mass of the piston is m, and area of the piston is A. So this piston is displaced, suppose x, from its mean position. This is the mean position, equilibrium position, and we have to displace this piston and x direction. So what happened? So here the pressure becomes P1, or here the pressure becomes P2, final pressure of the system, here pressure, and volume. What volume here? Here volume would be V naught minus this volume reduced here. So what is this volume? Area into x. This is area into x. This volume from here to here, and from here to here, the volume would be Ax V naught plus Ax. This from this here to here. So a force here acting P2 minus P2 into A, and here acting force would be P1 into A. So we write here restraining force, that is equal to, we write here, that would be P2 minus P1 into A. This is the restraining force. Restraining force. So we know an adiabatic process, P2, P naught, V naught, this is initial condition of the system. Gamma would be P1 V1 raised to power gamma. We are calculating here for this position. So P naught V naught raised to power gamma, P1 we have to calculate, and V1 is V naught minus Ax raised to power gamma, and divide by V2 raised to power gamma. This becomes P1, and 1 minus Ax upon V naught upon gamma. By the binomial expansion, if 1 minus x raised to power n, if will be 1 minus nx, if x is very less than 1. So here this term is very less than 1. So we can write here P naught is equal to P1 1 minus gamma Ax upon V naught. So what would be the P1? P1 would be P naught, and this would be 1 minus gamma Ax upon V naught on shifting upper. So this is 1, so minus 1 power. So this becomes P naught 1 plus gamma Ax upon V naught. Similarly, we have to find P2. So we on this on putting this value here, so we find P2. This would be P naught 1 minus gamma Ax upon V naught. This would be this. Because of this is volume is increasing here, so volume is increasing function, so pressure would be decreases. So here the pressure would be like this. So we find here restraining force, that is P2. So P naught 1 minus gamma Ax by V naught, and dividing this term minus 1 minus gamma Ax by V naught, and this becomes 1 cancel out, P naught minus 2 gamma Ax by V naught. This is Fr. Right here x. So this is Fr is equal to minus Kx. So this is the equation of SHM proved here. The system is doing SHM. So we write here time period is equal to 2 pi root m over k. So what is m here? M is the mass of the piston, m over k. So V naught, and this becomes 2 P naught gamma A. 2 P naught gamma A. P naught gamma A. A. A into x, area into displacement, A into x, V naught, gamma x, and so this is the if the process is isothermal, then gamma would be isothermal. If process is isothermal, gamma would be 1. PV is equal to constant. So this becomes for isothermal process 2 pi mv naught upon 2 pa p naught a. This is for isothermal. So this question is for adiabatic, and the time period in electrostatics, we also calculate here the time period for the system in electrostatics. So time period in the electrostatic system, suppose here is charge ring is here, this is charge ring, and this having q charge, and at distance x, and having radius r and mass m and radius r, and minus q naught charge is placed here. So we have to find the time period of the system. This minus q charge, this is minus q charge, oscillate. So we have to find here, so restoring force would be k q1 q2 upon r square, k q1 q naught into x upon r square plus x square raised to power 3 by 2. This is the restoring force, and we know x is very less than r, because of this is very near to this ring. We show here far away for the in diagram, but this charge is very near. So we write here Fr would be Q naught x upon this would be RQ. So this is the restoring force, and we write here this would be K and to x. This would be negative because of here the force in direction and displacement in the direction. So this is a SHM constant. So this is a constant for k. This is value of k 1 upon. So we write here k is 1 upon 4 pi epsilon naught. This is different. This is a spring constant. This is SHM constant, k SHM. This is a k. This is for 1 upon 4 pi epsilon naught. This is a electrostatic epsilon permittivity. So this is Fr is equal to k SHM into x. So we write here time period would be 2 pi. This value is k SHM. So this would be m r cube upon q naught x. X is the q naught. This is the time period here, and for the, if we have three equilateral triangle, and here if we have, suppose if we have a two charge here, plus q charge and plus q charge, and minus q charge is displaced here, and this is 2d distance. So we have to find the time period. Similarly, time period would be this, but two charges here. So this becomes t2 pi under root mr square upon mr square becomes md square. D is the distance from here. and this becomes 2k q naught. This is the time period for this charge. This charge oscillate just just like this, and we have to given here. This is a plus q charge, plus q charge, plus q charge. This is equilateral triangle. This length is L, this length is L. So we placed here from this is the centroid point to distance. Suppose this is x distance. A minus q charge is placed here. This minus q charge is oscillate in this segment. So we have find here. So this is a this is for this, and this is scenario for this. So minus q charge is placed from x distance from centroid. So where is the centroid here? So we know an equilateral triangle, we draw a circumcircle. So what is the circumcircle? This circle would be passes through this type, and the radius of circumcircle, this is the radius of circumcircle. So we have find radius of circumcircle, that would be ABC. This is equilateral triangle for any type of triangle which whose sides are not equal. So this becomes ABC upon 4 into area of the triangle. So ABC and triangle area. So we know why Hero's formula, that S would be summation of the sides, that would be L plus L plus L, so 3L by 2. This is A plus B plus C by 2, so this becomes 3L by 2, and Hero's formula is S into S minus A into S minus B into S minus C. So putting these values here, so S becomes 3L by 2, and this becomes L by 2, and this becomes L by 2, and this becomes L by 2. 1, 2, 3, 4. So 2, 2, 2, 2, 2, this becomes 4, and this becomes L square, and this root 3. So putting the value here, ABC means A cube. This means A cube. Sides are equal, ABC, this becomes L cube. L is the side. So 4 into root 3 L square by 4, this becomes R is equal to L by root 3. So this, in this scenario, we find time period, that would be 2 pi under root m r. R would be L by root 3 whole square. M r cube. Sorry, this is cube, not square. This is cube. This is also cube here. R cube. So this becomes cube. MR cube. L by 2 root 2 cube upon, and the charge is here 3. 1, 2, 3. So becomes 3. 3k q naught. This is for equilateral triangle. And when the position is here, this like this charge is placed, and at this is a suppose a this is suppose a this this is rectangular type shape, this is a square type shape, each length is L, and charge is placed in 4 corners, and we have to minus q charge is here. This is very not very distant, so this charge also do SHM. So a circumcircle made here, so the radius would be L by root 2. The R would be L by root 2 for this scenario. So time period would be 2 pi under root m d by root 2 whole cube upon 4 times of. This becomes 4k q naught, and k is equal to 1 upon 4 pi epsilon naught. This is the scenario in the electrostatics, and we find the uh, SHM in dipole. So electric dipole, we know minus the electric field lines would be negative to positive, and the direction of dipole is from negative to positive. So this is the dipole, minus q charge is here and plus q charge is here. Suppose 2d distance is here. So a electric field, the direction of electric field would be in this direction from negative to positive. If we shift this dipole, this is the direction of dipole and theta angle. So we know this do the angular SHM. For the angular SHM, we know for linear SHM, F R is proportional to X, and for this is linear for linear SHM, and for angular SHM, restoring torque would be proportional to theta. This is angular SHM. This is for angular SHM. So here we have to find the torque. Torque will be PE, that would be PE sin theta. We know the torque by the dipole. This is the dipole P. Here the direction of dipole, and this dipole is shifting. This is the direction of electric field. So we know the dipole would be P sin theta. This would be negative minus P theta sin theta is very small. So we write here torque is equal to P sin theta, and this would be I into alpha. If movement of inertia of the system, dipole system, so alpha becomes minus P by I equal to theta. Alpha becomes minus omega square theta. So time period becomes 2 pi under root I by P. This is the time period of dipole. This is the electrical dipole. Similarly, we write here for magnetic dipole, that will be I by mb. M is the magnetic moment here and B is the magnetic field. For electrical dipole, that would be I by P. For magnetic dipole, it would be I by mb. So these are some scenario I discuss here, and some topics we have to discuss for completion of this simple harmonic motion. So next video we uploaded the uh, topic regarding to related to SHM. So by this video, I think the conceptual and analytical approach of student would be increases, and this session would be highly having weightage for the students who are preparing for IIT and NEET. So thanks for watching this video, and take care.